This lesson will present a brief history of the universe, with emphasis on the formation of the Earth, oceans, and atmosphere. Let us begin by examining our current position in the universe. Our solar system is located about 2/3 of the way out from the center of the Milky Way, in the Orion Arm, just one of billions of stars in our own galaxy. Our solar system is rotating around the galaxy center at 280 kilometers per second, taking about 230 million years to go around once. And our entire galaxy is moving away from every other galaxy as the universe continues to expand. Now let's figure out how we got here. By observing how galaxies are moving today, and then running time backwards, scientists know that about 14 billion years ago, everything in the universe was located at one small point. Then suddenly, for complex reasons not completely understood, the universe began to inflate or expand, growing larger and larger as time goes on, and everything in the universe rushes away from everything else. At first, the universe contained only energy. Eventually, things cooled down enough for atoms of hydrogen to form and stars to start shining. The universe continues to expand today. Will it eventually shrink back to one point or continue expanding forever? Scientists are busy investigating this problem. The only atom made by the Big Bang was hydrogen, and maybe a little helium. Every other atom that exists in the universe was made inside of a star. The reaction listed above is a simplification of the basic way this happens. Hydrogen atoms inside the sun are so hot and moving so fast that when they collide, they fuse or stick together to form a new, larger atom, in this case, helium. Now, the larger helium atom that was made can collide with other atoms. When two helium atoms fuse together, they make beryllium. This process continues to form larger and larger atoms all the way up to iron. It also releases energy in the form of solar radiation, or sunlight. The small loss of mass during the thermonuclear reaction, one helium atom weighs less than two hydrogen atoms, is what produces a huge amount of energy according to E equals mc squared, or energy is equal to mass times a huge constant number. So every atom in the universe, besides hydrogen, was produced inside of a star, including the carbon that makes up your body and all the air you breathe. Atoms larger than iron are only produced by supernovas, when a massive star dies in a violent explosion. These explosions also send out into space all of the different larger atoms the star made from its initial hydrogen atoms. Our sun and solar system, like billions of others in the universe, formed from a cloud of gas and dust called a planetary nebula about 4.5 to 5 billion years ago. Although still mostly hydrogen atoms, it also contains larger atoms like carbon and oxygen made by older, dead stars. Gravity causes the planetary nebula to contract, and conservation of angular momentum causes it to take the shape of a rotating disk. Hydrogen atoms form the sun in the middle of the disk. Close in, only rocks and metal can condense into solids to form the inner planets. Colder gases and ices make up the outer planets. Accretion formed large planets, as small infant planets are constantly bombarded by smaller chunks such as other planets, asteroids, and comets. The planets that formed in stable orbits, where they did not collide with one another, survived to make up the solar system today. Not long after Earth formed, it was hit by another infant planet. Because Earth was still extremely hot and molten, the impact threw huge amounts of liquid rock into orbit around Earth. This material cooled and solidified into the Moon. Because the early Earth was molten, and large portions of it are still molten today, gravity caused the heaviest atoms, such as metals, to migrate to the center, or core, of the planet, while lighter atoms, such as nitrogen and carbon, moved towards the exterior. This process produced a planet with density stratification. The lightest materials are at the top, or exterior of the planet, and the heaviest materials are at the bottom, or core of the planet. We will see density stratification again when we look at the atmosphere and oceans. Most of the water that fills the oceans and produces clouds and rain in the atmosphere started out mixed into the interior of the molten Earth. Because of its low density, water vapor and other gases have been expelled or outgassed from the planet's molten interior throughout Earth's history. This process still continues today, adding more water to the ocean through volcanic eruptions. Some additional water for the ocean and atmosphere has been brought to Earth by comets, which are essentially dirty snowballs. A little bit more comet water is added each time Earth experiences a meteor shower, such as the Perseids in August, when the planet passes through the ice trail left by a comet. When Earth's first atmosphere formed billions of years ago, it contained somewhat different gases than it does today. Most notably, it did not contain oxygen, even though today's atmosphere contains 21% O2. All the oxygen gas has been put there by plants through photosynthesis.